Hey boys and girls, today we're going over Unit 8, Lesson 11. This is the last lesson in this unit. Make sure your name is at the top before we begin, and let's look at the do now. It says the graph shows triangle ABC and its image triangle A double prime, B double prime, C double prime. Describe a sequence of rigid motions which would map triangle ABC onto triangle A double, B double, C double prime. So the fact that I'm going from my pre-image ABC to a double prime tells me that two transformations must have taken place. And I know that's going to be true because I know that the keyword sequence means more than one. So I should be thinking of more than one rigid motion, rotation, reflection, translation. All right, so I got to pick two of those. That's going to map my pre-image onto my image here. All right, I'm going to start off by just looking at the image on the side here, this diagram. I can see my pre-image is on the right and my image is on the left. The first thing that I always like to look at is the orientation. That's the order of the letters. So as I move from A to B, I can see that that's turning back time. That would be counterclockwise. As I look at A double to B double, that's going to be clockwise because I'm moving forward in time. So since orientation has been changed, I know that some type of reflection has to have taken place. All right, so I'm going to deal with my reflection first. So now I have to figure out what's that line that I'm reflecting over, because I'm always reflecting over some type of line. Well, I can see here, if I look at the y-axis, just because it's already in the middle here, if I go 2 units to the right, I get C, and if I go 2 units to the left, I get C double. Same thing, if I go 4 units to the right, I get A, 4 units to the left, I get A double. So it looks like that line of reflection is going to be the y-axis. So I'm just going to highlight that. And that's what I'm going to fill in on the side here. That's my first transformation. It's a reflection over the y-axis. Again, a reflection is the only rigid motion that does not preserve orientation. So I'm going to actually reflect triangle ABC over the y-axis. So now I can see where my prime triangle would be, and that will help me get to my double prime. So again, instead of going 2 to the right, I want to go 2 to the left. So this is where C prime would have been. Instead of going 1, 2, 3, 4, 5, 6, 7, 8, 9 to the right for B, I'm going to go 9 to the left for, again, B prime. And then again, instead of going 4 to the right for A, I want to go 4 to the left, and this would have been A prime. I can go back and grab my straight edge here to connect that prime triangle. 1, 2, 3, whoop. All right, so now I can clearly see, well, how am I going to map my prime onto my double prime? Well, it looks like if I rotate, that's not going to really work out for me, so it's definitely going to be a translation. I just need to take this guy and slide him down, and he'll map right on. So that's going to be my second rigid motion. It would be a translation. When I translate, I have to be specific about where I'm going. If I go 2 units down, A prime goes to A double. Same thing for C and C, for C prime and C double, and B prime and B double. Oh my gosh, I'm so sorry, guys. Stumbling over my words. So I'm going to translate down 2 units. All right, and that would map my prime onto my double prime, and then I'm done. Part B says determine if those 2 triangles are congruent. All right, so is my pre-image ABC congruent to my double prime triangle? And you would say yes. Yes, they're congruent. And I know they're congruent because a reflection and a translation are both rigid motions, and they preserve everything. All right, so the way I'm going to say that is yes, because rigid motions preserve. And I can say they preserve side length. If you don't like to say side length, you can say distance or segments. Okay, one or the other. And they also preserve angle measure. So because nothing is changing, I know that those 2 triangles are definitely congruent. They are definitely the same. And now if we look at part C, determine if those 2 triangles are similar. Yeah, they're actually going to be similar as well. Because if 2 triangles are similar, that means angle measure is preserved. And I know that angle measure is preserved in a rigid motion. And I know that side length is in proportion, and I know that those sides are also in proportion. So I can say either one. I'm going to say because angle measure is preserved. Just because now it'll match. Angle measure is preserved in a rigid motion. That's what makes them congruent. And I know that angle measure is also preserved when two triangles are similar. All right, awesome. Let's move on to the bottom. Guided practice, example 1. Whoop. All right, so it says triangle ABC and triangle DEF are graphed on the set of axes. Part A, describe a sequence of transformations that's going to map ABC onto DEF. Again, sequence means more than one. Transformations means I could pick from all the 3 rigid motions and a dilation, all right, because there's 4 transformations. All right, so as I look here, the first thing I always, again, like to check is the orientation. So I'm going to follow the order of the letters A to B. I'm going to draw a little arrow here. And then again, D to E. I'm going to draw a little arrow here. So I can see that from A to B, I am turning back time. That is counterclockwise. And again, from D to E, I am turning back time. That is also counterclockwise. So that means that some type of rotation must be taking place. So I'm going to write that out on the side here. And again, those 2 triangles need to map onto each other. So I don't think I'm going to reflect just because orientation is preserved. I know that I'm going to end up with some type of translation at the end. All right. When I rotate and translate, I like to do the translation first. It doesn't matter, okay, which one you do first. But I like to translate first just because it becomes really clear to me where I need to rotate then to finish off the question. All right, just like in the do now, I could have translated first, but since I know a reflection took place, reflections again for me are not super challenging. I know that I just have to count the boxes, so I don't mind reflecting and then translating. But I could have translated first and reflected after. It doesn't matter the order, okay? So again, just for me, I like to translate first when I'm dealing with a rotation. So how am I going to translate ABC onto DEF? Well, I know that A and D correspond. So I'm really thinking, how am I going to get angle A onto angle D? Well, that means I have to translate up 1, 2, 3, 4 units. And then I also have to translate to the right 1, 2, 3, 4 units. So that's what I'm going to write. That's going to be my first transformation. It's going to be a translation of 4 units up because I have to describe where I'm moving. And I'm also going to translate 4 units to the right. Okay, and then again, I'm actually going to do that. So now I can see where my triangle lands. So this point is where A would now be. I'm going to translate up 1, 2, 3, 4 into the right, 1, 2, 3, 4. This is now where angle B would map. And then again for C, up 1, 2, 3, 4 to the right, 1, 2, 3, 4. And again, this is where C would have mapped. I'm going to go back just because it's nicer for me to form that triangle just to see exactly what's happening here, where triangle ABC would now be. All right, here we are. And now it becomes very clear, for me at least, to see where I want to rotate. Okay, so that's going to be next, a rotation. And I'm going to say that I'm going to be rotating around point A. You always want to start with your pre-image, okay? Because I'm moving A to D. So what that means, A got moved up, now it's here. And again, from my pre-image, I want to rotate around A because A and D are in the same spot. So I know that this would be my center of rotation. So it's a rotation about point A. And it looks like I'm going to rotate 180 degrees. These guys are like flip-flops of each other right now. So I know that if I take this triangle ABC and I rotate it 2 times, 1, 2, that would get me 180 degrees. All right, and that's what I want to say because I'm on the coordinate plane. I want to use angle measures here. So my center of rotation is A, point A. Here's my center of rotation. And then again, I'm going to rotate 180 degrees. All right, I don't have to say 180 degrees clockwise or counter because either way, that's going to be 2 turns to the right, gets me upside down, or 2 turns to the left, it also gets me upside down. I'm in the same spot, right? That same place. All right, let's look at part B. Is triangle ABC congruent, similar, or both to triangle DEF? And we have to explain. So this question is a little bit tricky. All right, you got to think about it carefully. So right off the bat, let's start with congruent. Are those 2 triangles going to be congruent? Absolutely. Just like in the do now. Both of these are rigid motions, and rigid motions preserve everything. So yes, they're definitely going to be congruent. Are they going to be similar? Well, if 2 triangles are similar, that means that angle measure is preserved. Well, angle measure is preserved, making them congruent, and angle measure is preserved. That would also make them similar. So yeah, they're actually going to be similar as well. So is it going to be both? It will be both, and explain. So here we go. If I want to explain why, again, the answer is both. I would say triangle, let's write this out, triangle ABC is congruent to triangle DEF because, well, I know they're congruent because both of these guys are rigid motions, and I know that rigid motions preserve side length. And again, you could say side length, distance, segments, whatever is going to float your boat there. So rigid motions preserve side length and angle measure. So they're definitely congruent, but they're also similar. So I'm also going to say triangle ABC is similar to triangle DEF because, again, because angle measure is preserved. All right. So sorry, guys. Having a hard time keeping this up here. All right. Questions, comments, concerns? Awesome. Let's go to the next page. All right, here we go. Let's look at example 2. All right. I went ahead and I just graphed in advance just to save us a little bit of time here. Okay, so if you need to pause and graph right now, feel free to do that. Part A, graph and label triangle ABC. There are the coordinates. I graphed it and I labeled it, so I know that part A is going to be completely done. I can give that a check. Part B, graph and label triangle A prime, B prime, C prime. Again, I graphed that in pink down below. I didn't just graph it, I also labeled it as well. So I am good to go with part B. I am totally done. Now let's look at part C. Determine and state a single transformation that's going to map triangle ABC onto triangle A prime, B prime, C prime. Well, I don't know if you can tell, but those 2 triangles are definitely not the same size. So that means that some type of dilation has to have taken place. So I'm going to start off by at least writing the word dilation, right? I dilate. It's a dilation. Oh, I'm sorry, dilation. And I know that when I dilate, I need to have a center of dilation and a scale factor. So I'm going to set myself up here. It's a dilation. Oh, wow. I really spelled that whole word wrong. I need to start again. So sorry. It's a dilation. Much better. Okay. With scale factor blank, because I don't know what that scale factor is yet. I'm going to figure that out. Centered at blank. Because again, I don't know what that center of dilation is yet, but I will figure it out. I'm going to do the center of dilation first because that's actually pretty simple. If you guys remember from past lessons, all I have to do is connect corresponding points, and where they cross is where my center of dilation is. That's why it's telling you to use your straight edge, use your ruler to get this question done. So I'm going to connect A and A prime because I know that those correspond. Make a nice straight line. Again, using your ruler, people. All right, I'm also going to connect B and B, or you know what, I'm sorry, let me make this line a little bit longer here. Okay, I'm also going to connect B and B prime because I know those correspond. And right away I can see that they are crossing at this point down below. If you wanted to, you absolutely could have connected C and C prime. Honestly, that's a little bit over the top, but it doesn't matter. Either way, all three intersect in the same spot. So I can see that my center of dilation here is going to be -4, -9. So I'm going to say my center of dilation is -4, -9. I'm going to put that bad boy in parentheses because I know that is a coordinate point, x, y. Now I have to see what the scale factor is. Okay, well, I can use my compass to do that, or I could really just count the boxes here because I'm on the coordinate plane. So in order for me to get from my center to A, that's going to be 1, 2, 3 boxes away. And then for me to get from A to A prime, that's another 1, 2, 3 boxes away. To get from my center to A is a scale factor of 1. To get from my pre-image to my image would be a scale factor of 2. It is 2 away from my center of dilation, so I know that the scale factor is going to be 2. All right. If I couldn't clearly count the boxes, then I would have used the compass instead. I would have measured the center of dilation to one of my pre-image coordinates. I could have picked point B. I'm using the inside hole here. And if I take my whole compass and just slide it up, I can see again when I look through, I'm seeing B prime. So again, this is a scale factor of 1. This would be a scale factor of 2. All right, so either way, I'm getting that number 2. And then part D, determine if those two triangles are congruent. They are absolutely not congruent. I'm going to say no, they are not congruent. How come, you ask? I'm going to say because side length is not preserved. So side length, again, you could say distance or segments. Side length is not preserved. Those side lengths are definitely different. I can see that my pre-image in purple is tiny and my image in pink is definitely much bigger. All right, so side length isn't preserved. And last but not least, let's look at example 3. Here we go. Triangle ABC and point D, 1, 2, are graphed on the coordinate plane. Here's ABC, here's point D. Part A, graph and label triangle A prime, B prime, C prime. Graph and label that image. The image is going to be using triangle ABC as a starter, all right? And I'm going to do that by using a dilation with a scale factor of 2, and it's going to be centered at point D, all right? Anytime I'm not dilating from the origin, I have to count the boxes, all right? So I'm really using slope here to dilate. So I can see that I'm using triangle ABC to start. That's important. And again, my scale factor is 2, and I'm dilating from point D. All right, so here we go. So from point D, how do I get to A? I'm always dilating from my center. So from D to A, I have to go to the left, 1, 2, 3, and down 1. That's a scale factor of 1. All right, but I want a scale factor of 2. So I have to go to the left, 1, 2, 3, and down 1 again. This is where A prime would land. Now from my center to get to B, I have to go up 1, 2, 3 to the left 1, but I got to do it again for a scale factor of 2. Up 1, 2, 3 to the left 1. This would be the coordinate for B prime. And then again, from my center to C, I have to go down 1, 2, 3 to the right, 1, 2, 3. But that's a scale factor of 1. I got to do it again for a scale factor of 2. Down 1, 2, 3 to the right, 1, 2, 3. And again, this would be the coordinates for C prime. I know that I have a pre-image that's a triangle. That means that my image will also be a triangle. I'm going to just go ahead and use my ruler to connect those points to form triangle A prime, B prime, C prime. And I want to just reread that question to make sure I answered it completely. Graph and label the prime I graphed it and I labeled it. I actually formed it as well, so I know that I am good to go. As I read part B, it says determine if those two triangles are congruent. Well, they told me that I'm using a dilation. A dilation definitely does not preserve side length. Those guys are two different sizes here, so they're not going to be congruent. So are they congruent? No. How come? Because side length is not preserved. Does anybody remember what is preserved? Wow, you guys are really on it today. Angle measure, nice job. Angle measure is always preserved in a dilation, but side length is not. And then part C, determine if those two triangles are similar. Different question. Yes, they are similar. How come? Because we just said angle measure is preserved. So if angles are preserved, the two figures are similar. If angle measure and side length are preserved, then they're congruent. All right, as we look at the final page here, page 3, independent practice, this is your homework. All right, make sure that you guys are reading all of these questions carefully. You are answering them completely, showing all work. Same thing with number 2. Read this question carefully, show all work, and make sure you are explaining using vocabulary at the end. All right, have a great day.